All right, so this is a example slash demonstration slash information video on some of the kit parts that either I sell at my shop or you may put together yourself. So this is the battery, this is the 18S2P using the 50S cell, it's the meat pack, and this is a ZBMS, but this would work if this were wired for example, the X-Lite BMS, or really anything involving this sort of harness setup. And this is a charger that I have adjusted down for 18S. It's a 4-amp charger. And I get these with an XT60, and I just make wiring adapters. That way this can then be used for any other 18S setup that has a different plug. So this is the XLR. The way I wire everything is the way I'm used to wiring it for other PEVs. It's positive is the red wire, and it goes into pin 1. Future Motion stuff is reversed. Their positive is on pin 2, and I believe pin 3 with their negative on pin 1. So the XLRs have markings. Pin 1 is positive, pin 2 is negative. You can, of course, open these up and rewire them however you'd like, but I'm used to positive being on pin 1, and that's just how it's wired. So the positive on here lines up, and then we get 75.6 volts. Positive on pin 1. So that's the charger. And this is the harness. It's connected to the 16-pin Molex, which is connected to that Molex header that would go into the flow glider box. And the way I have it wired, both for the kits that I offer in my shop and also just generally for aftermarket batteries that use a charge-only BMS, is that you have the charge port. Here's an XLR. Going directly to the BMS. And so that's what we're actually going to check. Now, that's the way these batteries have to be wired. It's the way that Z batteries have to be wired. And any sort of custom pack going into something like the Torque box or a XR box using a charge-only BMS, the charge port has to go to the BMS directly and not touch any other circuit. So this is the XT60 that would go into the VESC. That has its own larger gauge wires going through. And then in the kits that don't include a box, I leave these tinned but separate because you need to thread that through the cable gland, and then you would solder this on inside the box. I do have that in another video of me soldering on this connector. It's fairly simple because it's 2 wires, but that's not what we're checking right now. We're just checking the charge circuit. So here's how I check polarity. It's how I think it's a good idea to check polarity. And if one is building, as I do personally, with positive on pin 1 all the time, positive on red wires all the time, it's a bit easier to not worry about polarity, although it is still important to always check it no matter what. Plugging things in with a reverse polarity is the easiest way to break something, blow something up, and create a dangerous situation for the project that you're working on. And so that is what we're focusing on right now. To do so, you need a multimeter, and ideally a fluke. My fluke is lost. I don't know where it is. This is my backup, and I've put this through enough tests that I consider it fairly accurate and reliable. But either way, it is set up to the DC voltage. And what I'm going to do here is I'm putting these probe covers on the probes to make sure that only that fine tip is exposed, because we are going to check the polarity on a male connector. This has the pins, and therefore they are floating in space, right? If you're checking a female connector, like this is the main discharge connector for the battery, it's an XT90S, you'll notice that there are just 2 isolated barrels that sit recessed in the connector. That's fine if you have the long probe tips because they're each going to sit in there, and it's a bit difficult to get them to bridge and cause a short. However, if you're measuring a male connector like this male XT30, which is what plugs into the BMS, or if you want to measure at your charge port, for example, it's common in one-wheels and one-wheeled skateboards to have a male XLR as the charge port, which is a bit odd in e-skates and other PEVs. Usually you have a female connector for the charge port where it's barrels and they're recessed. It's hard to bridge them and cause shorts, but whatever. The point is that if you're measuring on a connector like this or the male XT30, using these probe covers will help to prevent shorts because the long posts won't touch and cause sparks and issues like that. And so the way I do it is I make sure I have it all wired up as it would be if it were on a board. So the charge port is on an XT30, fuse is right there, the fuse is inside there, and then this is what would be on the flow glider box, and so this would be mounted into the box, and then you would connect it, and that would be your charge port into your charge circuit, which goes through the charged wires, the harness out, and then we go here. And this XT30 is what would plug in to the ZBMS. So that's what we're gonna do. So what we're gonna do right now is we are going to plug in the ZBMS to the battery. And there is a connection order for this one. You plug the XT30 into the XT30 of the ZBMS. There's only one that'll fit. It is the female XT30 coming off the battery into the male XT30 on the ZBMS. And that's that. Then we connect the balance wires. Larger one first, which goes right there. And then this one goes right here. And there you go. Now your battery is connected to the ZBMS and it just works. So the charge port's going to connect to that one. This is a female XT30 and the male XT30 coming from the harness, which goes to the front to that charge port right there. So how do we check that? Well, the charger is on. We're going to do one quick check to make sure that this is the proper voltage and that the charger is actually on and active. And so we got this set to the DC voltage. What we're going to expect to see is a reading of the charger, which should be about, more or less, or ideally exactly 75.6 volts. Positive goes on pin 1, and I remove the probe covers because this is a female connector with the barrels in there, so we got to put them in there. And then we will see, all right, so it's a hair hot, but that's actually fine. 75.7. Should be 75.6, but 75.7 is fine. And so you'll notice that here, and it's very similar on other meters, there's no negative, there's no dash. If we flip them, by the way, so this means that it is reading the expected polarity. If we flip them and put positive on pin 2 and negative on pin 1, you'll see that we have the same voltage reading, but now there's a negative. So it's reading negative 75.7 volts. That means that the polarity is reversed. So if you measure something where you expect the positive to be on one side and the negative on another, and you get that negative symbol, that means that your polarity is reversed. And so you have to fix that before you actually plug in power sources to things. And so in this case, we're expecting positive on pin 1, and we're expecting negative on pin 2. And now it's reading regular voltage. And so that means that this charger is as I expect it to be, with the positive on pin 1 and the negative on pin 2. So we're just going to plug that in. So now we have simulated the board being plugged into the charger because it's plugged into the charge port, which means that this XT30 that would go into the BMS is now energized, or rather has a voltage on it. More accurately, has a voltage between those two pins. So we are going to put on the probe covers because we are going to check the polarity of those two pins. So this XT60 now has a voltage across these two pins of 75.7 volts, and this is what's going to connect to the ZBMS, and so we want to check that. We see the red and the black wires, which means this is the negative, and so this is always difficult on camera. Usually I would have this clipped to a helping hands thing, which, you know what? I'm just going to go and get that. Here's a cheap 3D printed one, which will do as long as it just holds it. That is good enough. As long as it's just sort of holding it. There we go. And so we're expecting the positive on that red and the negative on that black wire. There we go. And there we go. It's reading 75.7 volts, and there's no negative symbol there, so the polarity is correct because it's lining up the way we want. Just to show as an example again, if we read it the other way, you have a negative 75.7 volts. So red on red, that's where the positive should be. It is wired as expected with the expected 75.7 volts and no dash there to indicate that the polarity is reversed. Okay, so that's good. So let's disconnect that. and we will connect our harness's wiring to the ZBMS to do a final little charge test and make sure that it's working. So now this is connected to the ZBMS, which means that this charge port is connected to the ZBMS. We plug it in, fan turns on, light turns red, it is charging. That means that our charge circuits and ZBMS and battery are hooked up properly, and we're good to go in terms of this wiring.